Stop and think about this for a second. You're standing on a surface the size of 3 football fields. The deck beneath your feet is moving, not gently rocking, but lurching, pitching forward and slamming back down as 50-foot waves roll underneath you. Wind is hitting your face at 80 miles per hour. You can barely stand, you can barely see. And your job right now is to make sure that $70 million fighter jet behind you doesn't slide off the edge of the ship and disappear into the ocean. That's not a movie scene. That's a Tuesday for the men and women serving on U.S. aircraft carriers during storm season. In July 2022, they got it wrong. A storm ripped an FA-18 Super Hornet clean off the USS Harry S. Truman and sent it plunging 9,500 feet into the Mediterranean Sea. $70 million. Gone in seconds, into water so deep it took weeks just to locate the wreckage. And that wasn't even a hurricane, that was heavy weather. Now imagine a Category 5, 157 miles per hour winds, 60-foot seas, barometric pressure dropping like a rock, aimed directly at a carrier holding 64 of those jets. That's $4.5 billion in aircraft, on a floating runway with nowhere to run. The U.S. Navy operates 11 nuclear-powered supercarriers. They don't get to pull into port and wait out the storm. They operate 24 hours a day, 7 days a week, 365 days a year, regardless of what the atmosphere decides to do. Hurricane season runs from June through November. That's half the year where nature is actively trying to destroy the most expensive military assets ever built. So how do they do it? How does a floating city protect billions of dollars in aircraft, maintain combat readiness, and come out the other side ready to launch strike missions? That's exactly what we're breaking down today. And we're going deep. The engineering, the procedures, the history, the human failures, and the lessons written in tragedy that turn the U.S. Navy into the only force on Earth capable of doing this at scale. Let's start from the beginning. Before we talk about how they protect these ships, you need to understand exactly what's at stake, because most people have no idea how much money is floating around on one of these carriers at any given moment. Let's build the number from scratch. A Nimitz-class aircraft carrier, the older generation still in active service, costs $8.5 billion to build. The newer Gerald R. Ford class, the most advanced warship ever constructed, runs $13.3 billion. Just for the hull, just for the ship itself. Now let's talk about what's sitting on top of it. Each carrier deploys with what the Navy calls an air wing, typically between 64 and 80 aircraft depending on the mission. Here's the breakdown of what those aircraft cost. The FA-18 Super Hornet, the backbone of carrier aviation, costs $70 million per aircraft. The EA-18G Growler, the electronic warfare variant, runs about the same. The E-2D Advanced Hawkeye, the carrier's airborne radar and command aircraft, costs $80 million each. And then there's the newest addition, the F-35C Lightning II, the stealth fighter that's been replacing older jets across the fleet. That one costs $117 million per aircraft. Now do the math. If you've got 60 aircraft averaging $80 million each, you're looking at $4.8 billion in aircraft alone, sitting on top of an $8.5 to $13 billion ship, surrounded by a carrier strike group that includes cruisers, destroyers, and submarines worth billions more. We're talking about a moving concentration of military value that exceeds the entire defense budget of most countries on Earth. Countries like Portugal, New Zealand, Hungary, their entire annual military spending, all of it, wouldn't cover the cost of one fully loaded carrier air wing, and all of it is floating in the middle of an ocean that doesn't care. Here's something that makes this even more precarious, something most people watching from shore don't realize. During active operations, the majority of those aircraft aren't safely stored below deck. They're parked on top of the ship, exposed to wind, spray, salt, and whatever weather system is currently tracking toward the carrier group. Why? Because a carrier that has all its aircraft below deck is a carrier that can't respond to threats. The whole point of these ships is rapid response, the ability to go from zero to combat operations in minutes. That requires aircraft staged on deck, ready to launch. So you accept the exposure risk because the tactical requirement demands it. That tension between protecting the asset and keeping it operationally ready is at the heart of everything we're going to talk about today. Now let's talk about the ship itself, because understanding its design is the first step to understanding how it survives. A lot of people look at an aircraft carrier and think, that thing is enormous, it must be stable. And they're partially right, but the reality is more complicated and more fascinating. Let's start with size. A Nimitz-class carrier is 1,092 feet long. That's longer than the Eiffel Tower is tall. It displaces 104,000 tons of water when fully loaded. The flight deck alone covers 4.5 acres. These are genuinely incomprehensible numbers. But here's the thing about being that big on the ocean. You're not immune to the ocean, you're just fighting it on better terms. The hull design of a supercarrier incorporates a principle called metacentric stability. Without getting too deep into the physics, it works like this. The center of buoyancy, at the point around which the ship floats, is positioned higher than the center of gravity, the point around which the ship's weight is concentrated. What that means in practice is that when the ship tilts, physics automatically generates a correcting force. The further it tips, the harder physics pushes it back upright. It's essentially a self-righting design. The ocean pushes the ship over, and the ship's own geometry pushes back. That wide, flat underwater hull amplifies this effect. More surface area, creating more corrective buoyancy force when the ship tilts. But passive stability isn't enough in a serious storm. That's where the active stabilization systems come in. Modern supercarriers are equipped with massive gyroscopic stabilizers, essentially enormous spinning masses and hydraulic fin systems that automatically compensate for rolling motion. Sensors throughout the ship continuously measure roll angle, roll rate, wave direction, and wave frequency. That data feeds into a computer system that adjusts the stabilizer fins in real time, counteracting the roll before it builds into something dangerous. Think of it like active noise canceling headphones, except instead of canceling sound waves, it's canceling ocean waves. And instead of a small speaker, it's a system of hydraulic fins attached to a 100,000-ton warship. Then there's propulsion, and this is where American carriers have a decisive advantage over every other navy on Earth. U.S. supercarriers are nuclear-powered, 2 reactors, 4 steam turbines, 4 propeller shafts. They generate enough power to run a small city, and they can do it indefinitely without refueling for 20 to 25 years. Why does this matter for storm survival? Because in severe weather, the single most important thing a carrier can do is maintain the right heading. You want the bow pointed directly into the incoming waves. You want to be steaming into the wind, not across it or away from it. Taking waves on the bow distributes force along the strongest part of the hull. Taking them on the beam, the side, risks catastrophic rolling and flooding. Maintaining that optimal heading requires constant propulsion adjustments, sometimes at full power, fighting 60-foot seas to hold position, sometimes maneuvering to avoid the worst quadrant of a storm system. This kind of sustained, high-power maneuvering burns enormous amounts of fuel in a conventional ship. A nuclear carrier never runs out. It can steam at full power for days if necessary, making whatever heading adjustments the storm demands, without ever worrying about the fuel gauge. No other navy in the world, not China, not Russia, not France, not the UK, can match that operational freedom. China's carriers use conventional propulsion. Russia's Admiral Kuznetsov has spent more time in repair docks than at sea. Even France's Charles de Gaulle, a nuclear carrier, has faced repeated mechanical issues limiting its operational tempo. The U.S. fleet has 11 nuclear carriers operating simultaneously. That's not an accident. It's a deliberate, expensive, decades-long investment in exactly the kind of operational staying power you need when a Category 5 hurricane is bearing down and you can't leave. Now let's get up on deck, because this is where the real drama happens. The flight deck of an aircraft carrier is often called the most dangerous workplace on Earth. In normal operations, calm weather, clear skies, it's already a place where jet exhaust can blow you overboard, spinning propellers can dismember you, and arresting cables under tension can snap and cut a person in half. Sailors have died from all of these things. Add a storm, and you've introduced a whole new dimension of lethal. So when weather starts building, when the barometric pressure drops and the wind picks up and the carrier's weather team starts tracking a system, the flight deck goes into storm preparation mode. And it is an orchestrated, precise, non-negotiable process. The crew you see on the flight deck wears color-coded jerseys. Each color means something specific, and during storm prep, you need to know who does what. Yellow shirts are the aircraft directors. They guide every aircraft movement, where it goes, when it moves, how fast. During storm prep, they're coordinating the sequencing of which aircraft go below deck first, which stay topside, and exactly where each one gets parked. Blue shirts are the tie-down teams. In storm conditions, these are arguably the most critical people on deck. They're the ones attaching the chains that keep $70 million jets from becoming $70 million projectiles. Green shirts manage the catapults and arresting gear, both of which need to be secured and protected from storm damage. Brown shirts are plane captains, each one responsible for a specific aircraft, knowing that jet's status better than anyone else on the ship. White shirts are safety observers. In storm conditions, their job is to watch everything and stop anything that looks wrong before it becomes catastrophic. Now here's what storm preparation actually looks like on deck. The moment storm warnings go out, aircraft that can go below deck start going below deck. 4 massive hydraulic elevators, each capable of lifting 2 fully loaded fighter jets simultaneously, begin cycling. F-35s go first. Most expensive, most mission-critical, lowest tolerance for saltwater exposure. Then the Super Hornets in order of priority. As aircraft move toward the elevators, one of the first things that happens is wing folding. This isn't just a space-saving feature, it's a storm survival feature. An FA-18's wingspan and flight configuration is 40 feet. Folded, it drops to 27 feet. That 13-foot reduction per aircraft means you can fit dramatically more planes into the hangar bay below, and dramatically more onto a smaller section of flight deck for those that have to stay topside. The aircraft that can't go below, Ottadine or some helicopters, certain support aircraft overflow when the hangar is full, get positioned with extreme precision. Yellow shirts guide each one to its designated spot. Then the blue shirts go to work. In normal conditions, each aircraft gets 4 to 6 tie-down chains. In storm conditions, that doubles. In hurricane conditions, it triples. We're talking about 12 to 18 chains per aircraft, each one rated to 16,000 pounds of vertical load attached to deck fittings welded directly into the ship's structure. The chains aren't run parallel. They're crossed, forward and aft, port and starboard, creating a web that prevents the aircraft from sliding in any direction. And once they're attached and tensioned, they get checked, then checked again. Every chain, every fitting, every connection point. One sailor described the feeling of doing tie-down checks in a building storm. You're lying on your stomach on a deck that's moving, your face 6 inches from a fitting you're trying to inspect, and the wind is so loud you can't hear anything. You do it by feel. You do it by training. You do it because if you get it wrong, someone's going to watch that jet go over the side. The deck itself presents its own challenge in storms. Flight decks are designed with drainage. Scuppers essentially drain holes around the edges to clear water that washes over the deck. If water accumulates and isn't drained, you get something called free surface effect. Water sloshing from side to side amplifies the ship's roll, progressively destabilizing it. That's how ships capsize. The Navy takes scupper maintenance obsessively seriously before and during storms. Those drains stay clear. Water moves off the deck as fast as it arrives. 2 decks below the flight deck, protected by the carrier's steel hull, sits the hangar bay. And if the flight deck is the most dangerous workplace on Earth, the hangar bay is the most important safe room. The dimensions are staggering. 110 feet wide, 25 feet tall, 685 feet long. More than 2/3 the length of the entire ship. It's essentially a massive armored building suspended inside another massive armored building. The hangar bay is divided into 4 zones by thick sliding steel fire doors. These doors serve a dual purpose. They contain fires in wartime, and they contain storm damage in heavy weather. If one zone takes water intrusion or structural damage, the doors close and the other 3 zones stay protected. It's the same compartmentalization logic that keeps a damaged ship from sinking, applied to protecting aircraft. The bay's steel walls are thick enough to absorb significant wave impact. The elevators that connect it to the flight deck can be sealed against water intrusion. When the storm is severe enough, the hangar bay becomes essentially a watertight box. Aircraft inside, ocean outside, thick steel between them. Now here's a detail that trips most people up. The hangar bay has a fire suppression system that uses aqueous film-forming foam mixed with 94% seawater. This is standard carrier firefighting and enormously effective at smothering jet fuel fires, but seawater in an aircraft cockpit is catastrophic. Electronics, avionics systems, flight computers, all of it is destroyed by saltwater intrusion. A jet that survives a storm but accidentally gets its cockpit flooded by the fire suppression system is just as useless as one that went overboard. So before storm prep locks down the hangar, every cockpit canopy gets closed and physically secured. Every access panel, every equipment bay, every opening in every aircraft gets checked and sealed. Maintenance crews go aircraft by aircraft with checklists, verifying closure on every possible water intrusion point. This isn't paranoia, it's pattern recognition. The Navy has lost aircraft to accidental system activations before. The procedures exist because something went wrong once, someone documented it, and now everyone does it differently. Inside the hangar bay during a serious storm, it's quiet relative to the flight deck, but it's not calm. The ship's motion translates down here too. Aircraft secured with their own tie-down chains move against their restraints as the deck pitches. Maintenance crews continue working, running pre-flight inspections, fixing known issues, preparing aircraft for operations that will resume the moment the storm passes. Because here's the thing that separates U.S. carriers from every other Navy's approach. The goal isn't just to survive the storm. The goal is to survive the storm and be ready to fight immediately afterward. Aircraft that sit untouched during a storm may have developed maintenance issues from salt exposure, vibration, or water intrusion. Finding those issues after the storm rather than during storm prep means hours or days of delayed operations. So the hangar bay crews keep working, inspecting, maintaining, preparing, even while the storm rages above them. Every element of storm preparation we've talked about, the tie-downs, the aircraft movement, the hangar bay protocols, the ship's heading, doesn't happen automatically. Someone makes every single call, and the command structure that coordinates all of it is as critical as any piece of equipment on the ship. At the top of storm operations is the captain, the commanding officer of the carrier. The captain has final authority over everything. Ship's heading, speed, whether to maneuver away from a storm or steam through it when to begin storm preparations. Immediately below the captain in storm operations is the air boss, formerly called the Air Operations Officer. The air boss commands from primary flight control, or PRI-FLY, a glass-enclosed tower perched above the flight deck with 360-degree visibility. During storm prep, the air boss controls which aircraft move, when they move, and in what order. Every aircraft movement on the flight deck or in the hangar bay goes through the air boss. Working in coordination is the handler, operating from flight deck control one level below PRI-FLY. The handler uses a physical scale model of the carrier's flight deck and hangar bay, with small model aircraft representing every jet on the ship, to track the exact position and status of every aircraft in real time. This isn't a computer display, it's a physical board, updated manually as aircraft move because physical boards don't crash. The captain, air boss, and handler communicate constantly during storm preparation. And beneath them, department heads and chiefs coordinate their teams, yellow shirts, blue shirts, plane captains, maintenance crews, into a synchronized operation covering every inch of a ship the size of a small town. Here's where it can go wrong. In April 2025, the USS Harry S. Truman lost an FA-18 Super Hornet when it rolled backward off the hangar bay elevator and fell into the ocean. An investigation identified brake failure as a mechanical contributing factor, but it also found insufficient communication between the bridge, flight deck control, and hangar bay control. The ship had made an evasive maneuver. The aircraft wasn't fully secured for that kind of movement. The people who needed to know about the maneuver didn't know in time to take protective action. The brake failed, the aircraft moved, and there was nothing between it and the ocean. That investigation result, communication breakdown, echoes through carrier aviation history. It's almost never purely mechanical. There's almost always a human element, a message that didn't get passed, a procedure that got skipped because things were moving fast, an assumption that someone else had handled it. The Navy's response to that incident and to the broader pattern of aircraft losses during the 2024 to 2025 Red Sea deployment was enhanced communication protocols and stricter oversight across departments. Because the lesson is always the same. The procedure exists because someone learned it the hard way. None of the procedures we've talked about came from a comfortable boardroom. They came from disasters. December 17th and 18th, 1944. The Philippine Sea. 3 U.S. Navy destroyers, the Hull, Monaghan, and Spence, capsized and sank in Typhoon Cobra. 790 sailors died. It remains one of the worst weather disasters in U.S. Navy history. Aircraft carriers in that same storm, Kadawarinche Gdays, including the USS Monterey, came within moments of catastrophe. Fires broke out below deck from aircraft that had broken loose from their tie-downs and were rolling into each other, rupturing fuel lines. A young officer named Gerald Ford, then a 31-year-old lieutenant commander decades before the presidency, personally fought those fires while the Monterey pitched violently in 70-foot seas, slipping and falling across the flaming deck multiple times. Ford survived. The Monterey survived, but 790 other men didn't. The Navy commissioned a full investigation afterward. Admiral Chester Nimitz, Commander-in-Chief of the Pacific Fleet, oversaw a tribunal that examined every decision, every procedure, every equipment failure. The resulting reforms reshaped carrier storm doctrine entirely. New tie-down requirements, enhanced weather monitoring, clearer communication protocols between bridge and deck operations, mandatory storm preparation checklists, requirements for maintaining proper heading relative to storm winds and waves. The procedures blue shirts follow today when tripling the chains on aircraft in hurricane conditions. Those procedures trace directly back to what those fires on the Monterey's deck taught the Navy in 1944. Every major incident since has added new layers. Every lost aircraft, every close call, every investigation has produced new protocols. The 2022 Mediterranean incident, the 2025 Red Sea losses are they're being studied right now. Their findings will shape procedures for the next generation of carrier aviation. This is how institutional knowledge works at its best. You suffer, you document, you change. You drill the change until it's muscle memory, and the next generation of sailors doesn't have to learn it the same hard way. Here's the bottom line. The U.S. Navy has operated nuclear-powered supercarriers for over 60 years. Through Atlantic hurricane seasons and Pacific typhoons, through Arabian Sea monsoons and North Sea winter storms, through combat deployments where they had to manage storm conditions and incoming missiles simultaneously. In all of that time, through all of those storms, no U.S. aircraft carrier has ever been lost to weather, not one. That record doesn't happen by accident. It happens because of nuclear propulsion that never runs out of fuel, because of hull designs that use physics itself as a stabilizer, because of gyroscopic systems that fight the ocean in real time, because of hangar bays designed as armored compartments, because of 15-pound chains running crossing patterns by sailors in their early 20s who know that their hands are the last line of defense between a $70 million jet and the bottom of the ocean. And it happens because every time something goes wrong, every time a jet rolls off a deck or a storm exposes a gap in the procedures, the Navy investigates, documents, and changes. The institutional memory of 80 years of carrier aviation is baked into every checklist, every tie-down pattern, every communication protocol. Other navies have carriers. China has 2. Russia has one that barely works. France has one. The UK has 2. None of them have what the U.S. Navy has, 6 decades of hard-earned, battle-tested, storm-proven experience, and the will to keep updating it every time the ocean teaches a new lesson. The ocean always has more lessons. The Navy is always paying attention if you want to go deeper on how these carriers actually operate in combat, how they manage storm conditions and Houthi missile attacks simultaneously in the Red Sea. That breakdown is coming. Subscribe so you don't miss it. We'll see you there.